What do we notice about these two problems? What is interesting? Winter? They are both positively sloped lines. What else? Evelyn? They're almost the same slope. Well, let's check. Let's see how almost that is. Okay, we saw this one was a slope of 2, and as we come over and look at this one, rise 2, run 1, it is the same slope. These problems have the exact same slope. Okay, Posey?
The way that you can tell is because 0, -2 is your starting point, and 0, -2 is also in the...
All right. He also notices that they seem to have the same y-intercept. Okay, they both intersect the y-axis at the same point. They both have that point 0, -2. So the two things that you've noticed that are the same about these two lines make the fact that these lines are exactly the same. In other words, it took me 1 minute and 58 seconds to graph this line this way, and only 29.8 seconds to graph the line this way. So approximately 1/4 the time to graph it this way. Unfortunately though, that's because this one just gave us the point and slope, and this one gave us an equation. However, let's think critically. We said the two things that were common about this were the slope and the y-intercept. The slope was 2, the y-intercept was -2. When I come over here and look at this equation, what form of the equation is this? We know two forms of the equation. Nafisa. Slope-intercept. Now, let's think about this. Why do we think they might name this equation slope-intercept? Mr. Posey? So I think he's saying that he recognizes that maybe this, -2, is an intercept. Let's go back. Oh yeah, we said that was definitely something that was the same about this, that it actually had a y-intercept of -2. Okay, so that would definitely make sense for the intercept part. They did a really good job naming this because it gives us an intercept, it seems like. What about the slope part? Kevin? Yeah, it has the same slope. But why looking at this equation, what would make us think that they would have called this slope-intercept?
When you slope it, like it intersects.
What was the slope of this line that we calculated after we graphed it?
Positive.
Well, it was positive what?
2.
Okay, so it was positive 2. So now I'm looking again at this equation. Why might they call it slope-intercept? Posey.
They said it's slope-intercept because if you actually look at it, you can see that the 2 has the x, which the x would have been the 1 because it got the...
So Posey is saying he recognizes that it gave us the slope. So, somebody with a raised hand, explain to me really quickly, why do you think they call this slope-intercept form? Jackie. Because the equation gives you the slope and the y-intercept. Now, when I was given the slope and the y-intercept down here in this second problem, it wasn't given to me in equation form. It was just say, here's a point, here's the slope. It took me 1/4 the amount of time to graph it. So, using your brains, we can go ahead and combine the ideas that we had yesterday with the ideas that we are seeing today about how slope-intercept form really works. And now we can graph these equations without having to plug and chug. And as I showed you, not using plug and chug is much faster and easier because there are good dates, bad dates, etc., etc. Okay, so one of the key points I've already given to you today Because basically, we've already talked about the key points. We just need to figure out how to use those key points. So, the general form of a slope-intercept equation is y equals mx plus b, where m is some number, and that's always going to, whatever that number is, that's always going to be the slope of the line. And where b is the y-intercept. In other words, that's telling us where that line intersects the y-axis. In other words, it's giving us a point. So, one thing we also notice about this, it's y equals mx plus b. Y equals mx minus b doesn't count. But what can we do if we have a subtraction and we want it to be an addition? Leave chain switch. As an example over here, just so we make sure that we're incredibly clear, I have an equation that's y equals 1/2 x plus 6. So 1/2, m is 1/2, so that tells me that the slope is 1/2. My b over here has been replaced with 6, which tells me that 6 is my y-intercept. So we have a point 0, 6. Okay? So all we have to do is, to graph these equations that are in slope-intercept form, is to recognize the slope, recognize the point from the y-intercept, and use that to graph, just like we did all day yesterday. So, looking at this equation, y equals negative 4x plus 3. Everybody should be able to answer this question, so make sure that you're ready to answer this question. The question is, what is the slope of the line that this equation graphs? What is the slope of the line that this equation graphs? Everybody. Negative 4. Now, if we want to put that in rise over run form, we need to put a 1 underneath it. So we have negative 4 over 1 is our slope. That comes directly from our equation where negative 4 is our coefficient of x. So that means that is the slope. Now, I need a point to start from. Ricardo?
3 over 1.
3 over 1?
I mean,
not quite.
Rise over.
Armando? 0, 3. So this is the y-intercept. Remember, this is our y-axis. So this is telling us it's intercepting at 3 on this axis. So that point is 0, 3. So the y-intercept is 3, which means the starting point is 0, 3. Now all I have to do, rise negative 4, run 1. Rise negative 4, run 1. Just like we did yesterday. No big deal. Once we got our points, line it up.
This problem is so easy now.
Now, let's move over to the next one. This is y equals 2/3 x minus 2. What's not quite right about this equation for it to be in slope-intercept form? What is not quite right about this? Mr. Matlock? Well, there's something that this isn't quite in slope-intercept form. It's not quite y equals mx plus b. Matlock, try again.
Okay. I think that it is the 2 over 3. I think we need to multiply by this.
Damien, help him out. Yeah, we have a subtraction. It's y equals mx plus b. So I'm going to come over here, and I'm going to leave change switch. Now it's y equals mx plus b. So we see that we have slope-intercept form. So our slope is here. So that means our slope is 2 over 3. And our y-intercept is -2. That's where you have to be careful. If you have that subtraction in there, it's going to switch the sign of your y-intercept. So our y-intercept here is -2 because we did that leaf change switch. Which means our starting point is 0, -2. Graph my point, 0, -2. Follow my slope, rise 2, run 3. Rise 2, run 3. And we'll go ahead and get our line going through it. And that's it. So, as a summary of what we did today, let's talk really quickly about the benefits and why it's really, really nice to have an equation in slope-intercept form. Why is it so nice to have an equation in slope-intercept form? Ricardo.
It's easier and it's faster.
It's easier and it's faster to graph. No chances for good date, bad date issues. No chances for take the sign of a larger number issues. It's giving you a point. It's giving you a slope. All you've got to do is put it on the graph. Okay? So what we're going to learn later on at this point, let me ask you one quick question to make sure that we're all clear here. Does this work for any other form of the equation other than slope-intercept form? Kip yes or Kip no. Does this work for any other form other than slope-intercept form? No, it will not. So do not try to graph a standard form equation without doing plug and chug. At this point, you still have to plug and chug for standard form. But what we may learn later on is ways to take our standard form equation and make it into slope-intercept form. So that's something to look forward to. All right?